You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
The Cloud Native Computing Foundation, or CNCF, hosts critical components of the global technology infrastructure, including Kubernetes, Prometheus, and Envoy. CNCF is the neutral home for collaboration, bringing together the industry's top developers, end users, and vendors. Hello, and welcome to the New Stack Makers. I'm your host, Lorraine Lawson of TNS, and today we're going to talk about the future of cloud native and new developments we might see in 2026. For this conversation, I'll be joined by Chris Aniszczyk, the CTO of CNCF. Hello, Chris.
Hey, how's it going?
Good. How are you?
Good. Enjoying a start to 2026. So it's been a fun little break and now back in the swing of things this week. So still unbearing my email inbox like I'm sure everyone else is doing, but excited to get back into things for sure.
I feel that. Chris, obviously everyone who's watching or listening to us knows what the CNCF is, but would you give us a sense of what your role there is and what it involves?
Yeah, sure. I'm co-founder and CTO of the organization. Helped start it a little over 10 years ago as kind of the first interim executive director, and then eventually moved to a CTO role, which kind of oversees the technical aspects of CNCF. So we have our 200 plus projects that we host. We have a staff of CNCF staffers that help with things like project management, technical documentation, just all the things that you need for healthy open source projects behind the scenes. Obviously, we also put on a lot of events and all this other things. So it's kind of an interesting organization. But my focus is mostly on supporting our technical community and ensuring that our technical board, which is called the CNCF TOC or Technical Operating Committee, is staffed appropriately with help to kind of work on their mission of overseeing, improving, and removing and archiving CNCF projects. So that's kind of, I would say, the day-to-day, but obviously CNCF is part of Linux Foundation, and I have a broader kind of role there focused on developer relations and cloud and infrastructure things. So we're a big organization, even a larger organization, part of the LF. So hope that makes sense. We're busy a little bit the last, let's call it 6 months, launching a new organization called sister organization to CNCF called the AIF, Agentic AI Foundation, which hosts MCP, Goose, and other things. So it's just we're constantly busy and working across different areas at the Linux Foundation.
Well, it sounds like you're going to be the perfect person to speak to what we're talking about today, just cloud native. I guess let's get started. How do you distinguish between, say, cloud native and what we're calling AI native? How are they a reflection of each other?
Yeah, I think it just depends how you look at things, and I kind of want to differentiate between like AI native infrastructure and maybe AI native development. But for those in the audience that don't understand what cloud native is, we actually kind of have a definition put together by the organization that cloud native is all about an approach to kind of building and running scalable systems that essentially are resilient, scalable, and kind of use technologies like containers, microservices, orchestrators like Kubernetes to kind of enable this type of dynamic model of development, right? And we have a variety of projects that help fulfill that, mission, right? Kubernetes, orchestrate, gRPC may help you draft microservices. Projects like Prometheus and OpenTelemetry help with observability that's necessarily required for scalability and resilience. So it's all, CNCF is all about providing these pieces to really enable cloud native at scale, right? So, think about these like loosely coupled, observable, resilient, scalable systems. So AI native, I think in order to be AI native, you have to be cloud native by default. So AI, especially with the rise of agentic systems, is all about these kind of agents that come in, come out, do their work, talk to other agents, right? And if you kind of think about what an agent is at a surface level, kind of sounds like a microservice, and in my opinion, it is similar to microservice, but has a little bit different characteristics of how, it's scaled, managed, and so on. But, these systems, agents need to be orchestrated, observed, and so on. So I see cloud native really enabling AI native infrastructure. Taking that step a little bit further, if you kind of think about what an AI native developer, is, right? If you kind of think about the rise of these agents and tools like, Goose, Claude Code, and Kiro, all these kind of AI enabled IDs, essentially, my view of what an AI native developer, at least, is basically is someone that is using an agent or AI first approach to software development across the whole software lifecycle. So, if you kind of think about the software lifecycle, you have things like planning, design, development, deployment, maintenance, for a simple view of things, right? If you have AI that helps you maybe come up with PRDs, helps you maybe with design, helps you actually aid with development, things that help with testing, and obviously things that help with maintenance, like updating dependencies and helping with support for your project. So basically a developer that is using these tools on a day-to-day basis, what I would consider an AI native developer. But underpinning all that, in my opinion, is cloud native at the heart, and AI native infra that is powered by a lot of these cloud native projects. So hopefully that makes sense, in a simple kind of view here. But at the end of the day, I see agents very similar to microservices. These have to be secured, observed, and scaled just like anything else. And we have a lot of kind of commonalities in the cloud native CNCF world to enable those things. There's no secret that tools like ChatGPT, Claude, et cetera, all these things are powered by Kubernetes and other CNCF projects behind the scenes.
So moving a little off the IDE into more integrated AI, be more AI native. Is that fair?
I think so, depending how you kind of want to look. I think it's like AI native is a very broadly used term, and I think for me, I kind of view it as there's a line between an AI native infrastructure, which is very dependent on cloud native, and an AI native developer, which is using all these tools on a day-to-day basis.
Okay. Well, according to the CNF Kubernetes AI conformance, which is new, defines a set of capabilities, APIs, and configurations that a Kubernetes cluster must offer on top of standard CNCF Kubernetes conformance to reliably and efficiently run AI ML workloads. That's from the CNCF. So we wondered, what's the architectural convergence that's driving this definition and decision to pursue this?
So last year we made an announcement that we were putting together a group to work on a new effort under the Kubernetes and CNCF banner to basically extend our conformance efforts that we've done for Kubernetes itself to the world of AI. So the way to kind of think about this is, for people that aren't familiar with the original CNCF Kubernetes conformance program, basically any cloud you go to, private or public, whether it's Amazon has, EKS, Azure has AKS, Google has GKE, there's a ton of these Kubernetes standardized platforms out there. And behind the scenes of that is every one of those has to go through a conformance process, TCK, that is run to ensure there's like baseline API compatibility to kind of prevent, forking and incompatibility at a very, very base layer. And that program has reached 100+ products out there, clouds, distros. It's quite amazing. I think it's been responsible, at least, for a lot of the growth of Kubernetes, because at the end of the day, people want a stable system that they could, trust, right? It's not, magic in a way that, you use one cloud, you're magically moved to another cloud, but that baseline of Kubernetes makes it easier than it has ever been. So that was the baseline that's been very successful. And so with the rise of, agentic AI, generative AI, a lot of these folks had to go scale the infrastructure that is required to run, things like ChatGPT and a variety of different services, out there. As part of that scaling process, it's been a little bit complicated, say, to go scale your Kubernetes environments and cloud native environments to meet the demands of generative AI workloads, and a lot of people had to make some changes, right? Kubernetes itself, had beta support for things like GPUs, and with the rise of this kind of new feature that's stable in Kubernetes called dynamic resource allocation, or DRA for short. You basically support different types of accelerators like GPUs, TPUs, and so on for AI-based workloads within Kubernetes. There's also some changes that kind of have to be done on kind of a networking and traffic layer, because AI inference workloads, let's say, handle traffic a little bit differently than a typical microservice or HTTP-based workload. So you have to kind of make these changes to the base platform to kind of support AI workloads at scale. And so that's what this whole conformance effort was like. Hey, can we do the same thing that we did for the cloud native computing world of ensuring that everywhere you go, cloud, public, private, distribution, has some baseline of compatibility and support? Can we do that the same for AI workloads? Because everyone has been doing it differently across the industry, and it's been a bit of a mess. And so we decided to go launch that effort, and we made a big announcement late last year at KubeCon, North America, about a couple handfuls of companies coming together, including the big three, clouds, Amazon, Google, and Microsoft, to kind of go start this effort. So in my opinion, it's still a little bit early days, but our goal, at least within the CNCF, is to have basically every major provider out there, whether you're a big cloud or one of these like neo GPU focused cloud providers, to support this baseline of compatibility. That's what CNCF is good about. We're all about like, hey, bring a bunch of companies together, ensure that our workloads and tools run on every different type of cloud, every different type of GPU, TPU, CPU, et cetera. It's all about vendor neutrality and building community across companies and geographies.
Okay, you talked about that. You sort of got ahead of me on the problem that it solves, but how does it relate to Kubernetes conformance?
Yeah, so I tried to kind of tell you, basically, it's doing the same thing Kubernetes conformance does to ensure a baseline of compatibility across every Kubernetes distribution or product out there, but in the context of AI workloads. So ensuring that the cluster that you're running on properly supports the latest version of DRA, which allows you to use GPUs or maybe even TPUs or maybe some other form of ASIC system or whatever that people have built to run inference workloads. So there's a standardized level of networking and storage support that's required for these workloads. So it's all about extending what we've kind of done for the baseline criteria for Kubernetes conformance to the AI space and AI workloads.
Let's move on to the new incubating projects at the CNF. Can you tell us what's new and why they're part of the incubation program?
Yeah, maybe I'll talk about a couple, projects that I personally enjoy. But obviously we have a lot of projects in CNCF now. So we have two new projects that recently went through the incubating process. One is Metal³, which is a project that actually started out of a company called Ericsson, which is a large telecommunications provider, right? And a lot of those companies, what they need to do is they run Kubernetes on bare metal. So there is no cloud provider. They are essentially becoming somewhat a cloud provider. So they need a system to lay these clusters out, have them kind of provisioned and managed. And Metal³ does a fantastic job of basically managing bare metal infrastructure for the purposes of rolling out Kubernetes. On there. There's also some tight integration with OpenStack componentry, particularly a project called Ironic out of there. So sometimes a lot of folks that are doing bare metal deployments are using some OpenStack technology, and this helps kind of integrate a little bit better with that community, but obviously not required. So great project that is used a lot by I would say companies, particularly telco providers that are rolling out things on their own in their own data centers and kind of responsible for the whole provisioning management of Kubernetes itself, and not actually delegating that out to like a cloud or so on. So that's one of them that was recently announced to incubation. Another one, a lot of people sometimes don't realize that there are projects in CNCF that deal with kind of edge deployment. We have a project called KubeEdge, which is one of our graduated projects, but we also have an incubating project called OpenYurt, which recently hit incubating. And basically, the simplest way I can kind of describe OpenYurt is think of it as a control plane for managing edge-based Kubernetes deployments. They kind of created this CRD called Node Pool that kind of acts as a controller for all that at a high level. But for folks that are looking for creative solutions to how to scale out Kubernetes on the edge, I would definitely take a look at OpenYurt for that. And we've had a lot of cool keynotes at KubeCon about either retail stores or even kind of our famous Chick-fil-A example of Chick-fil-A running Kubernetes in every Chick-fil-A and kind of managing that. So these are kind of OpenYurt was kind of a project that would help with that particular case. But those are the ones that come to mind for me as kind of relevant new incubating projects that have recently been announced. But we have a lot more and only so much time to chat to.
Right. So training. Let's talk training. What's hot this year? What do you think will be hot in 2026?
What will be hot? So that's interesting. Obviously. I can't, from a CNCF perspective, it is very difficult to kind of get away from just AI infrastructure related needs. So basically, technology that powers and scales and observes agentic infrastructure is going to be huge. All of our projects, I think, are going to grow to meet those needs in CNCF. Sometimes, you'll have an existing project like OpenTelemetry will be refactored a little bit to support, monitoring and observing LLM and agentic-based workloads better than it had before. Just like Kubernetes is going through the transformation to, support GPUs, TPUs better through kind of projects like DRA. So that evolution for sure is happening. MCP support for almost every project that generally requires an agent to talk to is going to be a big theme, I think, this year. A lot of our projects already support kind of MCP out of the box, but I think there'll be growth in trying to ensure more consistent support across the board, at least from a CNCF perspective. I think a broader trend in general, I think MCPification of everything is already happening. We just announced this new foundation late last year called AIF, which hosts MCP. And to me, the crazy thing is, if you kind of look back, MCP is just a little over a year old now, and it's grown like crazy. And it's truly kind of the underpinnings for agentic infrastructure, for agents to talk to services and agents to talk to each other. So there's going to be a lot of that, going on. And as part of that approach, there's a lot of, let's call it agentic gateway. There's a lot of like new projects that are popping up to kind of support these things. So there's agent gateways. Basically, you kind of think of like a service mesh that's kind of repurposed to support AI workloads a little bit better. And we have projects in CNCF already. We have inside of Envoy, we have a project called AI Gateway that supports AI workloads using Envoy kind of as the base and control plane. There's Agent Gateway, another project out there, I think hosted by Solo and kind of an open source community that's being built around that inside the Linux Foundation. There's a lot of these popping up, and I think you're going to see a lot more experimentation in this space with more gateways popping up, and eventually with, in this kind of experimentization phase, there's always consolidation. I don't think we need 15 to 20 different agent gateways out there. It'll probably consolidate down to a few to a handful over time. But anytime there's a lot of early experimentation, that's essentially what ends up happening. The other thing that I think you'll see a trend that actually plays well into kind of CNCF and cloud native is I don't know if you want to call, these companies like NeoClouds. Sometimes I heard the word super cloud or micro cloud, but there's a lot of let's call it outside of the major hyperscalers. There are folks like, CoreWeave, RunPod, kind of these GPU focused providers that kind of really grew to support AI workloads. And then you kind of have smaller folks like your Cloudflares, Fastly's, et cetera, of the world out there. So I think you're going to see more of a rise of these smaller clouds being used to support a variety of different workloads. Because I think, with CNCF projects like Kubernetes, it becomes a lot easier to use a lot of these different, providers, out there. Both like, Akamai as a Kubernetes service, or like all of these folks are very, very conformant. And the great thing is with this kind of new AI conformance effort, a lot of these NeoCloud forward things are going to support this effort, which will kind of bring that kind of baseline compatibility and conformance, I think, required to kind of take advantage of a lot of these different NeoClouds. So yeah, I'll stop there. I could probably keep on go. I'm actually finalizing my kind of predictions blog post this week too for this year. So the timing is right to ask that question.
Yeah, the predictions. Now, I did wonder, the AI gateways, are they related at all to API gateways? Are they coming out of a kind of common heritage?
So similar. You think of like a traditional API gateways, right? You had, let's call it the Apogees of the world, Kongs. Those very much dealt with north-south traffic. And then you had the rise of service meshes, which were dealing with service communication, which was the people call it east-west. And then, service meshes were kind of combining all these, bits to kind of have one data plane and control plane to handle traffic. Now with AI workloads, there's, a bit of, indeterministic factor with these, LLMs and models where, hey, sometimes things fail, like sometimes things don't work out well. They're indeterministic on how long they may take. And so you need a little bit more intelligent routing that kind of exists. And so a lot of these API gateways, surface meshes, they're all doing their work to kind of support AI workloads better. So whether you call them AI gateways now, at the end of the day, it's like the same technologies. You have like bytes flow in, and then you have something that basically decides what to do with it, where to send it, how to route it. All these things are being extended. So all the traditional API gateway vendors are supporting AI workloads now. So in my opinion, I just don't think you're gonna. I don't think the world requires 15 to 20 of these things. I think you need a little bit less. But every like innovation phase has a consolidation phase for technology, especially as things that may have been proprietary get open source versions, and you kind of have this natural competition and consolidation phase that happens.
Well, thank you for being with us here today. That is all the time we have. I wanted to thank you again, Chris, for coming on board and talking with us today. And I want to thank all of you for joining us. This has been Lorraine Lawson of the News Stack, and we'll see you next time.
Awesome. Great to be here. Thanks for having me on the show.
Thank you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.